You're watching Code Like an Architect series with Adil Atta on Archi Wisdom. This is a class called Logger, which provides logging functionality. This is another class called Console Logger, which inherits from the Logger class. It's essential for this class to provide an implementation for the append log method, as it's an abstract method. Because of inheritance, all the public members of the Logger class are now part of Console Logger class. So any class using Console Logger will automatically have access to all the methods from the Logger. The Console Logger class can create its own new methods and also override the existing methods from the Logger class. Here, the Logger class is the base or parent class, and Console Logger is its child or derived class. We can also derive more classes from this, such as File Logger and Database Logger. A class can have multiple child classes, but it cannot have multiple parent classes. If C derives from B and B from A, it's called multi-level inheritance, and it's allowed. We can inherit as many times and to as many levels as we want. When different classes are connected through inheritance, it's called a class hierarchy. Inheritance gives you not just reusability, but rapid reusability. All you need to do is this, and all the public members of the base class are now yours. Maintainability. But be cautious, it can also cause low maintainability if not done correctly. Structuring. Extensibility. Substitutability, which is the key to doing inheritance correctly. Last but not the least, inheritance enables polymorphism. Just as it's important to know how to use inheritance, it's equally important to understand when to use inheritance and when not to use inheritance. Can we apply inheritance between any two classes, or is there a criterion? If so, what is that criterion? Common functionality? This is a car and this is a bird. Both have weight and color. Both can move and stop. These are common functionalities. So should we inherit a car from a bird or a bird from a car? This is a room and this is a glass of milk. Both have temperature. This is human and this is a tree. Both have height, both grow, and both take water. Common functionality you will find between any two things. Of course, common functionality is too generic and it cannot serve as a good criterion to decide inheritance. Generalization-Specialization. According to this criterion, inheritance can be applied between two classes if one is general and the other is a specialization of it. The general class will be the parent and the specialized class will be the child. For example, a vehicle is general, while car, boat, and aircraft are its specializations. Therefore, these three can inherit from vehicle. Following this rule, we can create a complete class hierarchy. For example, a helicopter, airplane, and jet are further specializations of aircraft. Is a relationship. Another criterion for deciding inheritance is the is-a relationship. X is a Y. If this statement holds true between two classes, it means there is an is-a relationship between them, and inheritance can be applied. For example, apple is a fruit, car is a vehicle, text box is a user control. Since these statements are true, inheritance can be applied here. On the other hand, onion is a fruit, book is a vehicle, text box is an array. Since these statements aren't true, there is no is-a relationship between them, and hence inheritance cannot be applied. In an is-a relationship, the left side represents the child and the right side represents the parent. Apple is a fruit. Here apple is the child and fruit is the parent. It's also important to note that the is-a relationship is unidirectional. Apple is a fruit is true, but fruit is an apple might not be true. A fruit can be a mango, banana, or any other fruit. Which of these criteria do you think is better? 1, 2, 3, or 4? When we create inheritance between two classes, it establishes an is-a relationship. At first glance, the is-a relationship seems like the most logical and intuitive way to decide when to use inheritance. But there's a catch. When we use polymorphism, it's crucial that child classes act as proper substitutes for their parent. This is important because it allows us to write generic code that works seamlessly with both the parent and its children. Think about it. When we say X is a Y, it implies that X can stand in for Y. In other words, any code that works on Y should also work on X. without any issues. Why? Because X is a Y. Similarly, an eagle is a bird. This means that any code that works for bird should also work for eagle. After all, eagle is also a bird. And that's exactly how polymorphic code works. But here's the problem. A bird can fly. An eagle is a bird and it can fly. An ostrich is also a bird, but it doesn't fly. Even though an ostrich satisfies the is a relationship with a bird, but it's not a proper substitute for a bird in all cases. The fly code that works on a bird will fail when applied on an ostrich. Scenarios like this create problem when using polymorphism, which is a key advantage of inheritance. Therefore, relying solely on is a relationship and other criteria listed here may not be the best approach to deciding inheritance. The correct criterion for deciding inheritance is substitution, meaning that a child class should be a proper substitute for a parent class, maintaining the integrity of the system. You will learn more about this in Liskov's substitution principle. When an object-oriented developer learns about the inheritance for the first time, the concept often fascinates them. This fascination leads to the overuse of inheritance, which causes several problems. You cannot even truly understand inheritance itself without understanding its problems and limitations. Learning those problems and limitations often leads to learning new ways of designing objects. We will learn them in the next video.